Welcome to Math 2318. This is section 1.6. In this section, we're looking at two examples and solving them using the techniques that we've been doing already. In question 1 here, we're looking to balance a chemical equation. What that means is, for example, here I've got B2, two B's on one side and only one on the other. I have a S, got three of them on this side, one of them on this side. I've got the hydrogens, two of them, one oxygen. So I want to balance it so I have the same number on both sides. So what this means is I've got a variable, some number times B2S3, some number times H2O, and that's going to yield X3 times H3BO3 and X4 of H2S. So I want to figure out what X1, X2, X3, and X4 have to be. Alright, so I need to make some convention for the problem. And so what I have is I'm going to write my vector in the order of B, S, H, and O. So for example, X1, now here I've got two B's and three S's. So that's why this is 2, 3. There's no hydrogens, there's no oxygens. On the next one, I have H2O, no B's, no S's, two hydrogens, one oxygen. And that has to equal to, let's see, I have one B, no S's, three H's, and three O's. And finally here on my last one, H2S, okay, no B's, one S, two H's, and no O's. Alright, so combine this now into a matrix. So here's my 2, 3, 0, 0, 0, 0, 2, 1. Now when I bring these to the left hand side, they're going to become negative. When these come to the left hand side, they become negative and it's equal to zeros. If I do row reduction on this particular matrix, here's what I end up with. And so what I see here is X4 is free. I can pick whatever I like. And so X3, all right, looking at this, the third row, I see X3 is 2/3 X4. X2 is 2 times X4. And X1 is 1/3 X4. So I'm free to pick whatever I like for X4. But since I'm trying to balance an equation, I'd like to pick a value for X4 that's going to make all the fractions go away. And I might as well pick the smallest one that works as well. So if X4 is 3, then these 3's cancel and X3 is 2. 2 times 3 is 6 and 1/3 times 3 is 1. And so we do get a balance on our equation. If you want to check, let's see, 2 B's. Yes, 2 B's. How many H's? Let's see here. I've got 6 and 6, 12 on this side. And 6 times 2 is 12. 6 oxygens, let's see, where's that? 2 and 3 of them here, so there's that. 6, 3 S's and 3 S's. So yes, it does balance. And in our second problem, We're looking at a general flow in a network, and we'd like to represent this in terms of a series of equations. And so we do this node by node. So I reproduced this picture down lower so we can take a look at this. All right, so what about node A? What can I see? Well, I see two things coming into A, one item going out. So what that tells me is x1 plus x3 must be 10. What about node B? Let's see, x2 is going in and x3 and 4 are going away. So x2 is x3 plus x4. What about node C? Well, 90 is going in, two nodes are coming out. So 90 is the sum of these two. All right, so let's see. If I write this now as an equation, I've got 1 here for x1, no x2s, 1 for x3, no x4s, and a 10. On this node, let's see, I got a 0 for the 1. For the x2, I've got a 1. Bring these two items to the left. They're both minus and a 0. Here, let's see, I got a 1, and no x3 and no x4, and that's equal to 90. All right, so what I did was I used this one to make a 0 under it in row 3. I then used this one to make a 0 under it, and that looks good. Okay. I then used this one to make a 0 there, giving me this in row reduced form. And so what do I see? I see x4 is 80. x3 is a free variable. x2 is 80 plus x3. And let's see, x1 is 10 minus x3. Now, one of the constraints was that each of these numbers has to be non-negative. So even though x3 is free, there's a limit as to how big it can be. Well, the biggest it can be is x3 is 10, because when it's 10, that means x1 is 0, and we can't have x1 be negative. And so the flow pattern would look like 80, 10, 90, and 0. So just a couple of problems to be able to solve using the techniques that we've been talking about.